Hello everybody. Today we're talking Objective 2 for our Algebra 8 course, Solving Equations. Equation solving is another foundational topic that you're going to have to be able to do all the way through algebra and all the way through your rest of your math career. So important stuff. Let's get going with it right away here. So first thing we're going to do is define the word equation. I'm going to say an equation is a mathematical statement that sets two expressions equal. Okay, so in our objective one, we talk about expressions. An expression is something like, we could just say x plus 2. That's an algebraic expression. And we can have something simple, like we could say 3 by itself as an expression. Okay, so an equation is where we actually set those expressions equal. We put an equal sign between two expressions. Today we're going to be working on solving equations. To solve an equation means to find the value of the variables that make the equation true. Okay, in other words, both sides of the equation equal to each other. Okay, so here I have x plus 2 on one side. I've got a 3 on the other side. When x equals 1, the left side will be equal to 3. The right side will be equal to 3. Okay, we'd have a true equation. We'd have the solution of that equation, the 1 then. Okay, now an equation can have one, none, or multiple solutions. Here's an example of an equation that has one solution, x equals 1. An example of something with multiple would be something like x plus 1 equals x. Okay, there is no solution to this because there's not a number that I can add 1 to it and get itself. We'll mainly be focusing on the one case. Okay, we're not going to really worry about the none. Multiple solutions, something like x squared equals 4. Okay, well for that, x could be equal to 2 or negative 2. We'll stick with the simple linear equations for this section, but just says you move forward through algebra, you will see the none case, you'll see the multiple solutions case. We'll do the simple cases here. So let's jump right into solving equations then. Problem 1 just says solve each equation for x. For part A, I've got something fairly simple looking. And what I'm looking to do is I want to figure out what value of x makes this equation true. In other words, what value of x makes the left side equal to 18, just like the right side's equal to 18 right now. Okay, to do that, what I'm going to do is what's called isolating the variable. I want to get the x by itself. I want to move all the other stuff, the other numbers, over to the other side. And I'm going to do that by, in this case, I need to get rid of the 3 on the left side. So I'm going to subtract 3 to cancel that out. Now, if I subtract 3 from one side of the equation, I need to do it to the other side. Okay, I can't just do things to one side of the equation. We need to keep this equation balanced. So what that's going to give us then is a negative 5x is equal to 18 minus 3 would be 15. Okay, I just did the same thing to both sides of the equation, so I'd say my original equation and the new one I have now are equivalent to each other. Now what I'm looking to do is to continue to make equivalent equations until I end up with the x by itself. Okay, so we subtracted away everything we could. Now what we're going to do is, since I have negative 5x or negative 5 times x, I want to undo that implied multiplication here. I'm going to do that by dividing both sides of the equation by negative 5. Okay, because negative 5 divided by negative 5 is just a 1. That'll cancel, leaving me with just the x on the left side is equal to 15 divided by negative 5 would be a negative 3. Remember, a positive divided by a negative will be a negative. All right, so we end up with x equals negative 3 for a solution to this equation. Okay, so when x equals negative 3, this equation is true. And I'm not going to do this step for every equation, but it's a good idea, especially come test time, to plug things back in and check. Okay, so if I go 3 minus 5, substituting in for the x, the negative 3, let's see what we end up with. Hopefully we get an 18. All right, so we have 3, if I do the multiplication here, negative 5 times negative 3 is a positive 15, so 3 plus 15, that is equal to 18. All right, good deal. I know I got the correct solution, okay, because when I plug it back in, things check out. Okay, that's part A. There's also a part B in your note guide. I want you to take a minute, pause the video, give part B a shot and then throw a hand up to get your answer checked. Let's make sure you're good with this stuff before we move on to the next example. Okay, once you've checked things out, once you got the okay, hit play again, you can pick up with problem 2. Next thing we're going to look at is solving equations involving fractions. Now, the fractions in this equation, the 1/2, the 5/6, might make it look uglier, but once we show you how to deal with those, we'll be back to our same simple equation we looked at in problem 1. Okay, so let's go ahead and do that. Now, most students don't like working with fractions. Okay, I know I don't like working with them. So your best first step with an equation with fractions in them is to get rid of them right away. And the trick for that is when I see this 5/6 y, I can think of this as y times 5 divided by 6. So to undo the divided by 6, what I'm going to do is I'm just going to multiply by 6. Okay, now if I do that to one part of my equation, I got to do it to every part. So I need to multiply the 3 by 6. And I also need to multiply this 1/2 on the other side by 6. And the times 6 will also cancel out this fraction here on the left. So what are we left with then? Well, we just said when I multiply by 6 and divide by 6, those two cancel. So this first term on the right side of the equation is just going to turn into a 5y. I'm no longer dividing by 6. We cancel that out. Okay, plus 3 times 6 would be 18. And on the left side, we have a 1/2 times 6. We can think of that as 6 divided by 2, which would just be a 3. All right, so multiply by whatever's dividing the y. And I suppose technically for this one, the 6 works out as the lowest common denominator. It's going to cancel both these fractions in one shot. And then once your fractions are canceled out, you're back to a simple equation to solve just like we had in the last problem. So let's go ahead and run through that. I need to get the y by itself. So I'm going to begin by subtracting away the 18. Okay, the 18s will cancel on the right. 3 minus 18 will give me a negative 15 on the left. So negative 15 is equal to 5y. And once again, that's 5 times y. To undo the 5 times, we'll divide both sides by 5. Okay, 5 divided by 5 is a 1, which gives me the just y by itself on the right. Negative 15 divided by 5 gives me a negative 3 on the left. All right, so again, when we're solving an equation with fractions, multiply to get rid of those fractions right off the bat. And then it turns into a simple equation. Same idea with part B. Take a minute, run through that one. So pause the video, run through that one. Okay, check your answer out before we move on. In problem 3, we're going to look at solving equations with variables on both sides. So solve each equation for n. I want to get n by itself in this equation. And the big difference here is notice that there's n's on both sides of the equal sign. There's n on the left side and on the right side. Now my goal is going to be to get everything with an n on one side of the equation, everything without an n on the other side, and then we'll be back to our simple equations that we can isolate the n for. Okay, so I can move this 2n to the right side of the equation, or I can move the 4n to the left. Either way works. What I'd recommend to do is keep the n on the side where it's bigger. Okay, keep the variable on the side with the bigger number, just because that's going to leave our answers positive. Okay, less negatives to deal with. It's going to make life easier. So the first step I'm going to do here is I'm going to subtract 2n from both the left and the right sides of this equation. Okay, that's going to cancel out the n's on the left side, leaving me with a negative 5 is equal to 4n minus 2n, it'd just be a 2n plus 10. Okay, so I've got all my n's to the right side. Now what I want to do is I want to get everything else to the left side. So for that, I'm going to subtract 10 from both sides to cancel out this plus 10 on the right. That'll give me a negative 5 minus 10 would be negative 15 on the left is equal to 2n. And now I can get n by itself. I'm going to divide both sides by 2. And this just happens to be one where I don't get a perfect number out. Okay, when you're solving equations, that's okay. Negative 15 divided by 2 will be a negative. We could say 7.5 for a solution to that equation. Okay, now if I want to check that, I'm not going to run through that in the video, but I'd plug the negative 7.5 into the left side, evaluate it. We plug it into the right side, evaluate it, and we should get the same answer out on both sides. Okay, go ahead, pause the video, run through part B of the note guide, check your answer, and then you can move on to the next type of equation. Next thing we're going to do is look at solving equations using the distributive property. So let's show you what we mean by that. Solve the equation for x once again. And notice here the difference is I have a variable, I have an expression within parentheses. Remember what this means when I have 7 times parenthesis x minus 5, that means 7 times the quantity of x minus 5. So to do this, what I need to do is I need to get my x out of the parentheses. So the first step I'll do is I'll distribute that 7 times the x and times the negative 5. Okay, so 7 times x we can just say is 7x. And 7 times negative 5 would be a negative 35. And that's equal to the right side 42 still. And once I distribute, I'm basically back to the same type of simple equation we started off with, where we can isolate the x. I've got 7x minus 35. To undo the minus 35, we'll add 35 to both sides. Okay, negative 35 plus 35 is a 0. Those will cancel. So we have 7x is equal to 42 plus 35 is 77. And then I'll divide both sides by 7, which will give me an x equals 11. All right, that's how you solve an equation using the distributive property. And like we said, distribute first, and once you do that, you're back to a simple equation. Go ahead, pause the video, give B a shot, check your answers before we move on. So in problem 5, we're going to look at solving equations where we have to start by combining like terms. So let's show you what we mean by that. We want to solve the equation for y. And notice I've got kind of an ugly looking equation, mainly because on the left side, the expression on the left, there's like terms that I could combine. I could simplify this side first. Okay, notice we have 2 terms with y's in them, and then also 2 constant terms, a 7 and a negative 3. Okay, the right side's simplified, but I can definitely make the left side look nicer before I start adding, subtracting, or multiplying, dividing. Okay, so anytime there's like terms on one side of the equation, combine those before we start doing things to both sides. So for that, I've got a 3y plus a 2y. 3y plus 2y is 5y. All right, plus, I can combine my constant terms as well. We have a positive 7 and a negative 3. 7 minus 3 would be a 4. Okay, in this case, the right side's already cleaned up and simplified for us, so nothing to do there. Okay, you could have the case where you have to simplify by combining like terms on both sides. Not in this case, though. And like we said, once we get like terms combined, we're back to our simple equation, where I'm going to subtract 4 on both sides to cancel this positive 4 out. So it'll leave me with just a 5y on the left is equal to a 5 on the right. And then we can divide both sides by 5, leaving us with a y equals 1 for a solution to that equation. Once again, if I want to check, I'm not going to take time in this video, but I'd plug in the 1 for both the y here and the y here. Okay, evaluate that left side. We should get a 9 once that 1's plugged in. Okay, once again, hit pause on the video, work through part B, check your answer before you press play and move on to the next problem. The next thing we're going to talk about are solving proportions. Okay, now a proportion is really just an equation setting 2 fractions equal. So for example, if I have 1/2, that's a fraction. I know that's equal to, it's the same thing as 2/4. And what we'll look at doing is we'll look at throwing a variable in. So instead of 2/4, we could say x over 4. And then what I want to do is I want to solve that proportion for x, okay, figure out what makes both sides of this equation true, or in other words, what makes both fractions equal. Okay, to do that, we're going to use something called the cross product property. Okay, it just states that if a over b equals c over d, then their cross products are equal, as in a d, okay, multiplying the diagonals, the crosses, a times d is going to be equal to b times c. So in this case, if I do the cross products, we'd have 2 times x would be 2x, is just equal to 1 times 4, 4. And by doing that property, we're able to get rid of the fractions, come up with a simpler equation that we can just divide with and solve for the x. That's how we get that x equals 2. You know, technically what's going on with the cross product properties, I'm just canceling both these fractions. If I multiplied both sides, quick, let's fix my 4 by 4. Okay, the 4's that cancel on the right. If I multiplied both sides then by a 2, the 2's that cancel on the left, that's giving me the 1 times 4 and the 2 times x. Okay, so we're really canceling fractions. Our cross product property just helps us kind of simplify that process and make life easier. All right, so let's look at solving some proportions. Okay, solve the proportion for x. We've got 3/7 over 9x. We want to figure out what x value makes these fractions equal. Okay, to do that, we're going to use the cross product property. We'll cross multiply and divide. So my first cross product is going to be the 3 times x, which we can just write as 3x. And that's going to be equal to the other cross product, 7 times 9. In other words, 63. Okay, cross multiply, then just divide. We can divide both sides of this equation we have now by 3 to cancel the times 3 on the left. That's going to leave me with x equals a 21 for a final answer. Okay, so x equals 21 is the solution by proportion. Now if I want to check that out, probably easiest way to do that is if I take 3/7 or 3 divided by 7 and plug it in my calculator, I end up with a 0.42857 on down the line. And then if I take 9 over the x we just found, 21, I should get the same thing. Yep, when I do that division, I get the same 4.2857 on down the line. Okay, so essentially doing the same thing when we check an equation. Okay, just seeing if those fractions give us the same thing when we're checking a solution for a proportion. Okay, same idea, part B, we'll give you a little cross multiply and divide practice. Take a minute, pause the video, run through that one, check your answer before you move on to the next question. Next thing we're going to do is look at solving proportions using the distributive property. Okay, or another way we could put it is just solving uglier proportions. And the reason this is uglier is notice I have multiple variables on both sides of my equal sign. And then also my expressions are a little more complicated. Rather than just a y, I have a y plus 4 here. Okay, but our kind of idea is going to be the same thing. I want to cross multiply. So we'll look at the first cross product, 9 times y, which we can just call 9y. We'll set that equal to the other cross product, which is going to be 3 times the y plus 4. And I'm going to write that as 3 times parenthesis y plus 4. Okay, because what I need to do here is I need to take 3, my denominator, and multiply by the entire numerator. So I'm going to have to distribute the 3 by the y and the 4. Okay, the big mistake I'll see from students on this problem is they'll forget to multiply by the 4. Don't do that. Okay, so that's going to leave me with a 9y is equal to 3y plus 3 times 4 is 12. Okay, so cross multiply, and that's a little more complicated than dividing. Essentially, I have a simple equation to solve now. We want to get y by itself. I'm going to subtract 3y from both sides. That's going to cancel the 3y on the left. That'll give me a 6y on the left is equal to 12. And then I'll divide both sides by 6. And we'll end up with y is equal to 2. Okay, so a little more complicated than a simple proportion with a single variable. Okay, but once you cross multiply, you're kind of back to where we were with some other equations we've already solved today. Pause the video, go ahead and give part B a shot, check your answer before you move on. Next thing we're going to do is actually use proportions to solve real-world questions. Okay, very handy idea. There's a lot of things in the real world that are proportional that we can use proportions to actually figure out solutions for. Okay, so let's go ahead and go through this one. Problem 8, part A. It says that a tree casts a 10-meter long shadow 10 meters long. At the same time, a signpost next to the tree casts a 4-meter long shadow. If we know the signpost is 2.5 meters high, we want to know how tall is the tree. Okay, classic indirect measurement question, and we're including one like this because I guarantee stuff like this is going to show up for you as you go through math, any type of math class. So what we have happening here is we have a tree where we don't know how tall it is. We'll call that x, but we can measure its shadow very easily. We'll say the shadow measures 10 meters. And at the same time, we've got a sign that is 2.5 meters high that casts a 4-meter shadow. Okay, again, this relationship should be proportional. We should have the same ratio from height to shadow and height to shadow between the tree and the signpost. So what I can do is I can set up a proportion and solve for that x. So what I can do is I can go height over shadow for the tree, so x over 10, and set that equal to height over shadow for the signpost, 2.5 over 4. Okay, so we have tree's height over tree shadow, signpost height over signpost shadow. And then once we have that set up, we'll just cross multiply and divide. X times 4 we can say is 4x is equal to 10 times 2.5, that'd be 25. Then divide. Divide both sides by 4, and that's going to leave us with x is equal to 6.25. All right, part B is another situation where measurements are proportional. Go ahead and read through that one. Okay, set up your proportion, solve your proportion. Okay, get your answer checked before we move on to the last question. Last thing we're going to do for equation solving is deal with something called a literal equation. I'm going to say that's just an equation that involves two or more variables, such as what we have down below here. We have the variables m, x, and a p. And we can't actually solve these equations for a variable and get a number out. What we can do is we can solve them for one of the variables and set it equal to an expression involving the others. Okay, we'll show you what we mean by that. Problem 9, part A says solve each literal equation for x. So in other words, isolate the x in this equation. Now to do that, the first thing I'm going to want to do is get all the x's on one side. And if I want to keep x positive, what I'll do is I'm going to add 3x to both sides of this equation. That's going to cancel out the minus 3x on the left. Okay, leaving me with just an m on the left is equal to 5x plus the p. And then what I want to do is I want to get the x by itself, okay, taking the same steps as if this m and p were numbers, we'll just treat them as variables instead. So what I do next is I would subtract p from both sides. That'll give me an m minus p is equal to 5x. Okay, because the plus p and minus p will cancel on the right side. M and p are not like terms, so I can't combine them. We'll just call them n minus p. And then last step is I need to undo this times 5 here. So I'm going to divide both sides by 5. That'll cancel the 5 out on the right, leaving me with just the x, so I've isolated the x. And on the left, again, I can't really simplify this, so we can just leave it as m minus p over 5. That's as simple as I can make that left side. Okay, that is solving a literal equation for a single variable. Now, my steps would be different if I was solving it for m or p. Okay, there's a lot of different ways these can work out. Try to pick one that was, showed a lot of the stuff that can happen. But there is a lot of good problem solving, a lot of good thinking skills you're going to have to use working your way through these. Okay, that's it for the video. Go ahead and give part B a shot. Okay, do make sure you check your answer before we move on to the Math XL. And we'll see you folks later.